Hello, everyone, and thank you for joining us. My name is Juliet, and I'll be the moderator for today's webinar. Before I pass it over to our speakers, let me cover a few housekeeping items. At the top of your screen are multiple engagement tools you can use. All tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your presentation area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical issues located in the Help widget at the top of your screen. Please note that a copy of today's slide deck and additional resources are available in the resource list. Please have a look and download everything that you may find useful. Also, the webinar will be recorded and sent via the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We're here to answer you live via the chat, so don't hesitate to reach out throughout the presentation. Now, I'd like to introduce our speakers. Today, we're joined by Sarah Gregory. She is the founder and principal consultant at Crary Labs LLC. She retired from Intel Corporation in 2024 as principal engineer of systems and solutions methodologies. At Intel, Sarah was responsible for the evolution of company-wide requirements engineering methods and practices, including training that is available through the IEEE Computer Society and published by OpenRE Initiative. From 2019 through 2024, Sarah and her team developed and deployed an innovative solution to manage highly complex product line data for the Internet of Things. She is recognized as an industry requirements engineering thought leader, served as an editor of the requirements engineering column for IEEE Software, and most recently co-chaired the Industrial Innovation Track for the 2025 International IEEE Requirements Engineering Conference. We are also joined by Steve Rush, Principal Solutions Consultant at Jama Software. Steve has over 15 years of experience in SaaS software implementation, solution architecture, and solution consulting. During his time at Jama Software, he's worked with customers in various industries, now specializing in semiconductor. He supports guiding customers on data model design, requirements authoring best practices, recommending data flow integration patterns, and so much more. And with that, I'll pass it over to you, Sarah.
Thanks, Juliet. And hey, thanks everybody for joining us today for a discussion about requirements engineering in the semiconductor industry. After over 20 years of tackling challenges of requirements within a semiconductor company myself, it's really great to be collaborating with the folks at Jama Software on the upcoming launch of a Jama Connect solution that's tailored for what we do. This webinar is an introduction to that solution, kind of a soft launch of a broader set of resources that will be released in just a couple of weeks, significantly expanding Jama Software's engagement in a sector in so many ways that's foundational to industries overall. In this webinar, we're going to give a brief overview of the current state of semiconductor requirements practice. We'll talk through some challenges that are common to semiconductor. Some are drawn from my own industry experience, but also from outside research publications and collaborations. These challenges may sound familiar to you too. And then we'll also talk about the value of intentional movement towards aligning product development data practices, both within your company or any specific company, but also for semiconductor overall. And we're definitely seeing folks start to pick up on that. These aren't alignments that a third-party data model or a standard is mandating for you either, but practices that have a solid return on investment in your context, both financially and in terms of quality and efficiency. Better alignment accelerates time to market and helps you respond effectively to change. A phrase that I found useful working in semiconductor about requirements, as well as requirements engineering generally, is common enough. Not identical, not uniform, not standard even, but common enough practices that an organization or team can coalesce around in order to build some efficiencies in their product development practice. There are many ways to move toward alignment on common enough practices, but we'll share just a few today, and Steve will show you what they'd look like in practice if you were to choose to try them out using Jama Connect. Steve will also introduce the Jama Connect Semiconductor Framework that will be launching on December 4th, the same day as a Jama-hosted Digital Engineering Summit in San Jose. We'll tell you a little bit more about that before we end today too. And of course, we're going to take some questions. We may not have time to catch them all in our short time together today, but please do put them in the Q&A. What we don't get to today, we'll try to tackle over the next few weeks, and we'll make available in the semiconductor area of the Jama Software website. So let's get started. A key first step in any collaborative engineering activity is to make sure that when you're using a term, you've got a shared understanding of what that term means. So when each of you signed up to attend today, you brought your own mental model of what we might mean by semiconductor. So let's take just a minute to orient on that with the model that Jama Software uses, describing 8 different categories of companies. Now, this isn't the only way to represent semiconductor, and there are certainly different degrees of difference or commonality among these groupings. So don't get wrapped around the picture here or those categories. It's just to let you know that yes, semiconductor, as comprehended by Jama Software, is a very broad and diverse sector with different data management needs. So for example, the requirements for a semiconductor chip, for a chip design, they're going to be different than the requirements for litho and etch equipment to fab that chip. Companies in some of the boxes may also exist in other industry categories, and they could be subject to standards in those industries as well. So it's all a matter of what an individual company does that it kind of informs what information they need to manage and how they need to manage that product data. It's also possible for 2 companies or more in the same sub-segment to manage their product data in very different ways, and then for there to be commonalities in company practices across those lines too. So it's not in the scope of Steve's and my discussion today to dig into these differences within the segments, much less different data management practices among them. Just know that the work that Jama Software is doing to support requirements engineering and data governance in the semiconductor industry, beginning with this initial release of the new semiconductor solution, comprehends the scope. We have 8 categories, a lot of overlap, but just as important, so many differences, sometimes even within a single company within one of those categories. And it's those differences, the scope and the breadth of them, that is a challenge that in many ways is unique to the semiconductor industry. Several industries, automotive, medical devices, even some areas of oil and gas, have prescriptive standards that govern how product data is structured, developed, and managed. If you've been following Jama Software for a while, you've possibly noticed a lot of resources that enable companies across those industries to deploy Jama Connect to manage their requirements, conforming to those standards. Jama Connect has several predefined traceability information models, or data models, and specific templates that are purpose-built to accelerate the work of companies that need to meet those standards. So in semiconductor, we don't have such a standard at the point of product definition. You may have your own mental model of the information architecture at your company, or at least in the part of the company where you're working. And if you happen to work in a standards adjacent area, for example, your company or the part of the company that you're in provides devices to automotive, standards that govern the automotive industry may be familiar to you, at least for that part of your business. Otherwise, even within the same subsector in semiconductor, you're going to find a lot of differences, a lot of divergence in how companies may architect their product data. In the absence of prescriptive standards that govern product information architecture, a lot of that information architecture has just grown up organically. Now, when you look across semiconductor as a whole, you might see some resemblance in some areas, but in others, the information to be managed is quite different. So, no standards, no common regulations, very different products, all leads to a lot of divergence in practice, and that divergence can create drag and inefficiencies. Now, that points to one of the common traits across many companies in the semiconductor industry too. A lot of companies are working with a set of ad hoc requirements practices that may be workable in the context of a team or small organization, but they don't really scale when you need to share data across different teams. Or if schedules speed up and it's critical to understand the program status, or if one team's product is itself an ingredient in a larger system of systems along with other products. So a phrase that we use sometimes to talk about these ad hoc solutions is, we say they are locally optimized. Now, that's not a criticism. In fact, many times these ad hoc practices, even if they're implemented initially in OneNote or Word or Excel, they can do a great job of representing the mental model that folks working in that area have of their product and its design. So local optimization can be great if you just need to work with that information in that local context. Everybody works with it, they're familiar with it, and it's really tailored for that very specific data. Now, in some companies, these ad hoc practices can even be institutionalized in homegrown tools, and those can provide some efficiencies too. But what may be perceived as efficient at a local scale, gets more challenging as different pockets of local optimization take shape across the enterprise, each one developed by people working in that very specific area. So the risk, think of something like trying to track the impact of a change in one part of the system to another part of the system that manages their data really differently. That can be a pretty substantial risk. Other areas where ad hoc or disjointed processes and tools can introduce risks are, let's say, when a defect is found. Maybe it's in test, maybe it's post-release. So we found a defect, we need to track it back up from where it was first cited, maybe through hardware, code, product architecture, design, requirements, possibly even all the way up to the customer who requested the feature that's now at risk, or possibly even has it deployed in production. It's nearly impossible to do that traceability and follow that lineage without some sort of common digital web that shows those data relationships. A series of teams or organizations working with their own locally optimized ad hoc practices is almost like having a whole group of people that are, very familiar with different languages, different terms, but don't have any common way to communicate. So, these aren't uncommon challenges. Maybe as I've talked through that, they remind you of some things that you've experienced yourself. And it's not just something that Semiconductor deals with. Regulated industries aren't immune from them either. They just get a helping hand to try to make some of those connections or build that common language in the form of some of the prescriptive processes and structures that come from regulations and standards, and that takes on some of the burden. A common response that companies may take when they realize the challenge of having all of this divergence is to adopt a tool, possibly with a data model derived from one of those standards, that's different from the locally optimized structures. Now, the idea that there's quantifiable benefit to moving to more state-of-the-art requirements, practices, and tooling, that isn't controversial. But the hardest part is often the belief that moving from the current state, as we sometimes call it in requirements engineering, the adhocracy, to scalable, governed, consistent requirements practices, can sound really overwhelming. And I want to be clear, that's a very reasonable concern. Many companies have experienced one or more requirements or data management transformation initiatives that for various reasons simply failed to deliver on what was promised when they started. So the gap between what folks believe is possible and what they've experienced can be really significant. And that gap can be a deterrent and build some resistance to try to make things better. The time, budget, and resources to do it often aren't top priorities for most companies. Now, why then is it advisable maybe to not try to aim and transform everything at once, but work towards something common enough? Common enough is not a phrase that's especially common, especially not when you're attempting to build a disciplined practice and drive quality and efficiency. My previous career, when our little team of systems and requirements engineers first started talking with both leaders that were holding me accountable for driving a transformation and engineers who frankly just wanted to do their jobs, having some sort of common enough starting point gave us a good footing to begin the work. Now, I've never encountered anyone who's told me that their ad hoc practices, requirements in Excel, changes to requirements may be coming in through email, possibly from customer engagements or customer communications at trade shows. Nobody ever said, this is perfect, our processes and they meet all of our needs. As you may have found yourself, different teams or groups with different ad hoc practices, one may be writing product requirements documents in Word, another one may be doing them in Excel, can spend so much time struggling with documentation that it takes time away that would be much better spent delivering phenomenal products. These ad hoc practices, if the commonality is just everyone using locally optimized templates in standard business applications, that's probably not going to make it over that bar of being common enough. But there's a flip side to that too. sometimes the response to the adhocracy can swing the pendulum too far in the opposite direction. There are a lot of ways that that can happen, but some common ones are to adopt a framework with the expectation that every team across the enterprise can just modify their data and make it fit. And depending on the complexity of the products in the environment, your best case could be possibly learning that resistance may not be futile. Talented engineers and teams will find a way to get work done, even if it's through performing steps that are required for the inflexible system, but maintaining a back-channel ad hoc set of documents. Now, this isn't pointing at any specific company or even at semiconductor industry as a whole, by the way. There's some great research happening at the University of Utrecht right now, not at all focused on semiconductor, that's exploring the nature and persistence of ad hoc requirements. It's a big challenge, and a lot of work is underway to figure out why does this work and how do we start moving towards something that's a little bit closer to that common enough point. Successful transformations are evolutionary. Common enough practice needs to have a solid and stable foundation. You can improve the quality of your written work, but if you're continuing to manage product definitional data in disconnected repositories or business applications, you're still going to be challenged by inefficiencies. But once you have a stable foundation, a single source of truth for your data, even if the information's not yet consistently organized, or requirements and architecture may be structured differently in different areas and not yet connected to the customer and stakeholder needs that justify them, you can add other practices and start to move toward that commonality. So yes, there's definitely research happening that supports these assertions, but also I've lived through them. And each of you can probably identify an area where what you and your company are doing today could be better. And then because you're attending a Jama Software webinar, I bet you're already familiar with some of these concepts and you're at least curious about what changes, maybe even incremental ones to start, might address some of those challenges. So tools and solutions aside, one of the advantages that regulated industries have is the governance that comes from standards that specify how certain work gets done. They have, if you will, common enough practices coming from those standards in key areas that are given to them. And as a result, those shared practices, even in different tools, even managed different ways, give them some distinct advantages. So even in the absence of prescriptive standards, I'd suggest that taking some steps beyond locally optimized solutions, and yes, even steps that could be applied across a wide variety of teams in a semiconductor company, or even companies across the semiconductor industry as a whole, can produce quantifiable business results. So here's just a few options of places to start. First, consistent cross-organizational communication of status, a phrase that we used all the time. Visibility leads to accountability. If you can see the relationships across all of the information in a product or product line, or even starting off small with something like a shared glossary in one location that everybody has access to and references when they're writing their documents, it'll reduce the inefficiencies of crossing team and component or ingredient boundaries. And the gains from this are nonlinear too, especially when you're looking at a product line context or working with complex systems. A small incremental change can deliver very significant value and do it pretty quickly. Something else that adds a lot of value but seems pretty simple are reviews, and doing your reviews slightly differently. If the accountability for the quality of the information that defines the products that you're developing is shared between the authors of that information, data creators, and the engineers who are using that data to drive their work, that gives you much better communication, but also much more accountability. The folks that are receiving the content to drive their work need to be actively engaged, providing feedback and ensuring that that feedback is heard and incorporated as needed. There's good research and solid practice experience that shows a decrease in defects during development and test when definitional data, requirements, and other early stage content gets that level of scrutiny. And then these expectations add rigor to the question of when your requirements are considered good and done. Getting not only that shared accountability for quality, but knowing what version of data is plan of record and having one understood process for managing changes to the data with the same visibility across the organizations as above. Accurate information then isn't just communicated, but it's always available anytime anybody needs to see it. that ensures that everyone's on the same page with what the work is to be done, what the plan of record is, and when and how that changes. These all are steps that can deliver quantifiable value, but also can be begun easily, especially once you have that single source of truth or a common foundation that you're working from. So where do you start with common enough then? Bear with me for a second. Another common trait I've noticed when I talk with folks in semiconductor companies about requirements and data governance practices is that if I mention that word standard, I encounter resistance pretty fast. And standards can be perceived as slowing down work, absolutely, inserting unnecessarily bureaucracy, prioritizing process over delivering excellent products, and doing all of this in such an incredibly competitive market is seen not necessarily as an advantage. I found my best success pulling teams across an enterprise together on common enough practices to come when I didn't use that S word at all, standard. If you have to sell it, or if the way it's implemented slows people down or just isn't usable, you're missing an opportunity to do it better and take advantage of those common practices. The goal is for better practices to produce not only quantifiable value to the bottom line, but also value, efficiencies, and even skill advancement for the people who are doing the work. These are 4 prominent sources of practices that, if they're designed and applied well, they will do just that. Now, I'll note here that there are some semiconductor standards that are supported with some automation here, things that happen typically down in manufacturing. JEDEC 046 is a great example for product process change notifications, and some of the other open JEDEC standards. They're supported very well when they're used in a system where requirements practices are more consistent too. So I'm not going to say anything more about standards today. That's not why we're here. Instead, I'm going to turn the mic over to Steve Rush, who Julie had introduced earlier as Jama Software's Senior Solutions Consultant working in semiconductor. The new semiconductor solution from Jama Software doesn't label itself as adhering to ISO IEC IEEE 29148. That is an advisory standard on requirements engineering. But you know what? It doesn't have to. Several aspects of this standard are incorporated into Jama Connect out of the box. Others are readily available as add-ons. And in those cases, it's not even important that anyone know that the standard is out there. It's enough that the semiconductor solution in Jama Software enables these common enough practices.